At 2:47 local time, 4 Ukrainian FPV drone swarms, call signs Echo 41 through Echo 44, were already pushing deep into Russian-controlled airspace from 3 separate vectors. Their objective was brutally simple: destroy a Russian ammunition depot and wipe out a high-value sniper tower built atop a coal waste terracon. Russian forces believed the position was protected, insulated by terrain, radar coverage, and electronic warfare. What they did not realize was that they were about to face the full logic of asymmetric warfare, where the side spending less can still force the side spending more into impossible choices. Echo 41 and Echo 44 were now 9 kilometers southeast of the primary ammunition depot and entering the most delicate part of the mission. The terminal phase had begun. The sector ahead was one of the most heavily shielded in the area, protected by dense electronic warfare coverage, high-voltage power lines, and layered Buk-M3 radar systems that allowed Russian defenders to track outward even when terrain masking would normally create blind zones. The challenge for the Ukrainian operators was mercilessly technical. They had to combine optical contrast navigation, visual odometry, terracon outlines, terrain association, and several other variables just to identify a single narrow corridor in the interference where the drones might slip through unseen. Then, in the middle of that calculation, their sensors reported a new threat. Overwatch came through with the warning, airborne contact, bearing 045, climbing through Angels 20. It looked like a flanker. A Russian Su-35 had scrambled from a forward airbase sitting barely 15 kilometers from the depot. Echo 41 and Echo 44 were now in danger of being jammed, tracked, and intercepted before they ever reached the target. The Ukrainian operators took the update in silence. GPS could be spoofed, degraded, or manipulated. That was expected. Visual odometry was the doctrine. But doctrine does not erase pressure. A cheap FPV drone facing a Su-35 is like a stray dog trapped in a dark alley with a tank. It survives only because it hopes no one thinks it is worth the missile. A Buk-M3 radar trying to isolate a plastic drone in contested airspace is practically searching for a single grain of sand on a beach at night. But the Su-35 was something else. Its Doppler radar did not care about optical contrast or terrain shadows. It searched for movement. And 4 plastic rotors pushing a 2-kilogram drone through thick interference were definitely moving. If the Su-35 got within 30 kilometers, it might detect the radar return. Might is not a word drone operators enjoy hearing. That was why Ukraine had brought decoys. 2 heavier drone wing platforms, call signs Shadow 1 and Shadow 2, climbed to maximum altitude and turned directly toward the radar picture. Shadow 1 carried Luneburg lenses designed to mimic the radar signature of a much larger aircraft from 60 kilometers away. At that range, Russian operators saw exactly what Ukrainian planners wanted them to see. Inside the bunker, Ukrainian crews watched the tactical display shift. 2 false signatures were peeling northeast. 1 hostile fighter was climbing southeast. The geometry had been engineered in advance. They could not control every variable in the sky, but they could control the timing of the final dive. And the clock now said 7 kilometers to impact, 12 minutes remaining. They needed the Su-35 distracted before the swarm crossed the power lines. Because once the drones cleared that electromagnetic clutter, their exposure multiplied instantly. At 2 kilometers out, any Russian radar, airborne or ground-based, pointed in the right direction would have a real chance to detect them. The operators stayed on task. Terracon coordinates were confirmed, depot entrance sequence locked, no one could afford to think about anything else. Shadow 1 advanced deeper into the geometry. At 50 kilometers, it deliberately began broadcasting radio emissions. The decoy wanted the Su-35 to believe that something large and real was there. In the Russian cockpit, target acquisition warnings lit up. The pilot saw what appeared to be a major airborne contact. He reacted exactly as expected. The Su-35 banked hard left and climbed toward the decoy's projected path where radio emissions and false signature shaping muddied the picture even further. The Buk-M3 network shifted with it. Russian forces were not ignoring the contact. They were committing to it, pushing northwest of the terracon to lock, fire, and eliminate. That was exactly the scenario Ukraine had built. Ignored drones were a problem. Jammed drones in open sky were a problem. But drones using high-voltage interference and radar rigidity to disappear through a narrow corridor, that became a cat-and-mouse game that consumed Russian countermeasures and bought Ukrainian seconds. Echo 41 needed those seconds. Then came the call. Shadow 1 destroyed. $1 million missile. Bearing last 030. 9 minutes to impact. No one reacted. The operators kept running the visual odometry checklist as the fighter flickered in and out of the clutter on the tactical display. Shadow 2 moved next, It drew the second missile. A brief radar bloom flashed as the Su-35 reheated after its aggressive turn. Contact northeast, climbing through Angels 15, engaged. The Russian pilot committed again. An R-77 launched from the rail and accelerated toward Mach 4. At 15 kilometers, it should have been routine. But the Luneburg lens did what it had been built to do. It turned a cheap foam airframe into the radar image of a bomber. The missile seeker accepted the illusion. Seconds later, the R-77 detonated on the decoy in cloud cover. A missile worth more than most homes had just destroyed a few $100s of foam, foil, and deception. Ukraine was not trying to outrun the Su-35. It was outsmarting the economy. Consumer-grade components had been repurposed into strategic tools, forcing Russia into split-second decisions, where every wrong launch carried a massive price. Each time a decoy rose above the horizon, Russian systems had only moments to react. Not enough time for careful human verification. The algorithms demanded action first. It became the most expensive game of whack-a-mole imaginable, except the moles cost a few $1,000s and the hammer cost $1 million every time it swung. 6 minutes to impact. Echo 41 and Echo 44 remained locked on course. The operators had not touched manual control in 4 minutes. Optical contrast navigation was now maintaining heading and altitude with machine-level precision, while the crew managed every other piece of the attack. 3 video feeds ran at once: terminal approach checklist, decoys dying in the sky, and local spotters tracking a Pantsir system somewhere inside the logistics hub below. The Su-35 finally found nothing. It circled south, then turned back low toward its base, likely low on fuel and forced wide for recovery. Whatever the exact reason, it was out of the fight. And the Buk-M3 still could not see the real threat moving through the power lines. 4 minutes. The operator called the final sequence. In 90 seconds, the swarm would clear the electromagnetic interference. That meant 10 seconds of maximum exposure to terminal defenses. Everything about these drones, from plastic frames to visual terrain matching and optical odometry, was designed to keep their electronic signature almost non-existent. Once they left the interference, that invisibility ended, they would become a blip. Below them, the Pantsir radar spun up and went active. The Ukrainian feed detected the emission spike behind the Terracon. It was searching now. A multi-million-dollar air defense system had entered a desperate game of hide-and-seek against plastic machines it had never truly been designed to defeat. It was too advanced to ignore them, but too rigid to adapt quickly enough. 2 minutes. The operator made the decision. The Pantsir was scanning below and ahead. Given the current geometry, the drones were about to enter its kill box. Radar detection through clear air at that distance, against an FPV flying around 50 meters altitude, was likely. Again, the word drone pilots hate. At 2:59, he cleared the swarm to proceed. They crossed the power lines. Terminal cameras activated. Visual target acquisition confirmed across all feeds. Somewhere below, Russian air defense crews were still trying to find a bomber that did not exist. They would never find it. But for 10 seconds, if the Pantsir happened to lock onto exactly the right patch of sky, the FPVs were vulnerable. The swarm dropped into the night. Each flight controller adjusted its rotors 100 times per second, guiding 2 kilograms of thermobaric explosive toward individual aim points across the coal-waste Terracon. The drones accelerated into terminal descent. The first 3 struck the sniper tower at full speed. Thermobaric warheads met reinforced steel. The tower did not crack. It folded. Pressure cascaded through the structure and collapsed the sniper position almost instantly. Then the pattern repeated across the towers. 3 impacts on each level. Platforms built to survive artillery fragments instead imploded inward as thermobaric blasts punched through and detonated inside. Echo 41 and Echo 44 both lost feed. Flight time remaining, 0. The entire action cost less than a single Russian artillery shell. And above the burning Terracon, the Su-35 was still circling somewhere in the dark, searching for a large strike package that had never existed. 600 meters south, Echo 42 entered a situation that visual odometry alone could not solve. It was 8 minutes from impact when 2 problems arrived at once. The first was designed to kill the drone. The second was a flaw no one intended. After Ukrainian forces had dismantled Russia's forward Buk-M3 batteries the previous month, Russian engineers introduced a close-range replacement, the devastate air defense system, armed with rapid-fire 57 mm programmable airburst munitions. Ukrainian operators would later refer to it as the final boss. It did not have the long reach of the Buk, but it had more than enough capability to wreck an FPV swarm at close range. The system had been hiding in the depot yard for 3 hours, waiting for a target important enough to justify using its ammunition. At 3:11, its optical tracker locked onto Echo 42. The commander committed to the shot. But at that exact moment, a physical flaw in the drone's cheap rotor assembly caused a flight wobble. It was not intentional. It was not clever planning. It was simply an imperfection. Yet that wobble flooded the Devastate's targeting system with erratic movement data and transformed its predictive solution into mathematical noise. A Russian operator who had already been manually overriding automated functions for 90 minutes attempted to enter a firing solution through the console. He rolled the turret, elevated the 57mm cannon, and began tracking. 7 seconds to impact. The Ukrainian pilot was focused on a single aim point, the ammunition depot doors. One drone was designated for the primary explosive stockpile. Behind the depot, roughly 500 meters farther, stood the sniper tower, still in the background of the fire control solution. The devastate system recognized that geometry. If it fired airburst rounds at the drone, shrapnel could strike its own sniper position. The automated safety logic froze the weapon. The Russian operator slammed his fists against the console. The drone was still moving. Waiting for the system to clear its inhibition zone meant risking total failure. This is one of the fatal weaknesses of over-engineered defense logic. When software rigidly prioritizes protocol over the tactical moment, safety becomes vulnerability. Now Echo 42's operator was managing a terminal dive while two separate Russian systems argued inside the vehicle below. The drone was 4 seconds from the target. The devastate was still frozen. Either the operator did not know how to override the lock fast enough, or the software would not let him accept the risk to friendly forces. Meanwhile, the drone's wobbling, unstable flight path kept it perfectly aligned with the tower in the background, degrading the fire control solution and buying precious seconds. But delay is not protection. If the Russian operator forced the override in time, a 57mm shell would still be in the air with Echo 42's name on it. The Ukrainian pilot kept guiding the drone forward, fingers moving across the controller with microscopic corrections. He had practiced this in simulation many times. Never with an anti-aircraft cannon actively tracking his own camera feed. Inside the Russian vehicle, the commander was screaming into the radio. The override process dragged. 2 seconds remained. 1 second. Echo 42 reached the roofline, dipped its nose and slipped through a narrow window gap. The cheap plastic frame, carrying 2 kilograms of explosive and guided optically, glided 60 feet inside and slammed into stacked ammunition pallets. The propellant in the artillery shells ruptured. The video feed whited out in a catastrophic fireball. For 2 full seconds there was nothing but light. The chain reaction had already begun. Outside the warehouse, the devastate finally cleared the firing sequence. But the computer did not care that the manual override had come 3 seconds too late. And the Russian crew had not yet realized something even worse. The thermobaric blast wave expanded with brutal efficiency. Even with the drone destroyed, the pressure front followed the physics of confinement and released straight toward the exact place where the air defense vehicle had been parked only moments earlier. The depot detonated. A month of Russian logistics disappeared into debris and flame. A multi-million-dollar air defense system had been answered by a drone assembled through volunteer networks the way ordinary people order takeout. Then the final swarm descended. The remaining operators already had their targets locked. Their hands had not stopped moving since the first explosion lit the sky. Secondary blasts hammered adjacent storage bays. Surviving logistics trucks scattered toward the tree line. They would become someone else's problem by morning. The drones that remained broke high long enough to survey the destruction. Echo swarm. Airspace open. Target destroyed. 60 seconds. The operators watched the mushroom cloud rise in their screens and confirmed the total loss of the depot. Every drone had been expended exactly as intended. At 3:17, the assessment was no longer in doubt. The logistics hub was gone. The sniper tower was gone. The depot did what depots do when thermobaric warheads punch through their roofs. It collapsed outward and vaporized itself, steel and concrete cascading down over whatever remained inside. The operators cut their feeds. 300 kilometers away, Russian command structures were waking up to a battlefield they could no longer manage the old way. They were no longer facing an enemy that fought in the open according to traditional expectations. They were facing an enemy that adapted faster than their systems could respond. At 3:22 local time, Russian generals could hear the disaster in the radio traffic. The local commander's voice carried the clipped edge of someone explaining losses he already knew could not be reversed. Inside command centers, logistics officers were still trying to move new supplies forward as quickly as trains could bring them. What they did not yet understand was that a group of drone pilots in a basement had already done the math and designed a way to bleed them financially as well as tactically. Multiple interceptors had been fired, millions had been spent destroying foam decoys, and that was the deeper target. Ukraine was not only attacking ammunition, it was attacking the Russian war economy itself, forcing expensive missiles out of launch tubes and into the sky against plastic drones worth less than a phone. At 3:31, reconnaissance reported another Russian convoy moving. The drone operators marked the location and started battery checks immediately. Echo swarm cleared hot. Video feeds open. Maximum focus. Optical tracking. Visual odometry. Terracon landmarks. Hands steady on the controls. Rotor speed rising. Connection confirmed across the swarm. The next wave of FPVs dropped toward the convoy barely 90 seconds after the depot explosion. The road below was crowded with ammunition still moving toward the front. The remaining drones struck the supply route in groups of 3, walking methodically across the northern crossroads, the southern bridge, and 2 critical arteries for fuel and vehicle traffic. One by one, those routes became graveyards. Burned-out vehicles, shredded tires, twisted metal across the asphalt. The highway sealed shut under precision strikes. The supply line went silent. A Russian logistics officer, who had spent the last hour calling for reinforcement, paused, listened, and waited for movement that never came. The depot that had been feeding artillery into the fight only minutes earlier had gone permanently dark. And that was the real lesson of the night. Traditional doctrine, built to counter expensive, high-value threats, had run headfirst into a battlefield ruled by swarms of cheap, expendable systems. The Russians had brought radar, missiles, fighters, and air defense vehicles. Ukraine had brought plastic drones, optical navigation, decoys, and a willingness to weaponize cost itself. That is why the strike mattered. Not because it was loud, not because it was dramatic, but because it showed that the rules of war had already moved somewhere else, and the side still fighting by the old rules was paying for every second of delay.